Okay, Chapter 7, Quiz 1, review. So we're starting off here, kind of going backwards. This is the most recent topics we learned, and it's rewriting in the same base. So we looked at 27 and 3, and we want to find out what base they both have exponentially. So 27 can be rewritten with a base of 3. 3 to the third power. Okay? 3 times 3 is 9, times 3 is 27. And on this side, 3 is already 3. It can be written to the first power, but that's not necessary. So we just write it as 3. Now, here's the important thing. This 2x minus 4, which was the exponent for the 27, is still an exponent. But we've added this exponent here. So we need to put the 2x minus 4 in parentheses. And over here, the 5x does not change. And now we can pretty much throw away these numbers and set this equal to that. So 3 times 2x minus 4 equals 5x. Distribute 6x, 3 times 2x, minus 12 equals 5x. Subtract 6x from both sides. Negative 12 equals negative 1x, 5x minus 6x. And now we can't have a negative x. We need to divide by negative 1 and get x equals positive 12. Okay, number 2. A common mistake here is to say, oh, 16 is 8 times 2. So we have 8 times 2 and 8. That's not what we're talking about. We're not talking about multiplication facts. We're talking about exponents, powers. So 16 and 8 both come from the same number. Okay? 2 for each of them. Now 16 is 2 to the 4th. 8 is 2 to the 3rd. The x plus 1 stays, but in parentheses, and the 2x plus 4 stays in parentheses. And again, we're going to throw out the 2. We don't need it anymore. We're going to set this equal to this. Now, if you want, you can go ahead and distribute right now and go right to the next line and say 4x plus 4 equals 6x plus 12. If you want to take the extra line and say 4 parentheses x plus 1 equals 3 parentheses 2x plus 4, that is perfectly fine. So just check your math. 4 times x is 4x, 4 times 1 is 4, 3 times 2 is 6, 3 times 4 is 12. Now, I want to get 4x on this, over here to the right side. And at the same time, I'm just going to move the 12. 4x's cancel. This is negative 8. 6x minus 4x is 2x, and the 12's cancel. Now I divide by 2, and I get x is equal to negative 4. Now, as soon as you see a fraction like this, remember, something special occurs. 5 cubed is 125. 5 times 5 times 5. But 5 to the negative third is 1 over 125. So whenever we see it to the bottom, we go, oh, well, let's see, 5 to the third is 125. Well, we have to remember to make it negative because it's on the bottom, it's in the denominator. And this 5 just stays. Over here we have x minus 2. And over here we have x plus 8. And we don't need parentheses because we're not distributing anything. Again, we're going to set these equal together to each other because we're throwing those bases out. I'm just going to distribute here because of space. Negative 3x, careful, plus 6 equals x plus 8. I'm going to add 3x to both sides. And I'm going to subtract 8 from both sides. Those cancel. 6 minus 8 is negative 2. 3x plus 1x is 4x. And the 8's cancel. Now I divide by 4, and I I get x equals, careful, negative 1/2. 2 divided by 4 reduces to 1/2. Remember, if you need to at any time, hit pause, rewind, whatever you need to do. So notice I have two fractions, so both of my exponents are going to be negative. What base becomes 32 and 8? Well, that would be 2 again. 2 to the what is 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's 5. But remember, it's in the denominator, so it's negative 5. 2 to the third is 8. So 2 to the negative 3 is 1/8. And then we have 4x minus 1. Now, throw out these. I have nothing to distribute on the left side. It is just negative 5 is equal to negative 3 times 4x is negative 12x. Negative 3 times 1, negative 1 is plus 3. I'm going to add 12x to both sides. Sorry, no, I'm not. That would be silly. I'm going to subtract, not an 8, subtract 3 from both sides, which will give me negative 8 equals negative 12x. I divide by negative 12, and I get x equals to be positive 8/12, which reduces what goes into 8 and 12 to, but bigger than that, GCF, greatest common factor, would be 4. 4 goes into 8 twice, and into 12 3 times. Okay, number 5, 64. Well, again, kind of look back at number 4, 2 to the 5th is 32, so 2 to the 6th is 64. And then we have 2x minus 6 equals 2. Oh, I have to write equal signs so high. 2 squared is 4, and then I need a parentheses for x plus 2. So 6 times 2, I can throw these out. 6 times 2 is 12x. 6 times 6 is 36, and it's negative, equals 2x plus 4. I'm going to subtract 2x from both sides. I'm going to get them over to the left. I'm going to add 36 to both sides, get that over to the right. Here I get 10x. 36 is canceled. 2x is canceled, and I get 40. If I divide by 10, x is equal to 4. Over here, I see a fraction, and immediately I think about the fact I'm going to need a negative exponent. So 3 is already as low as it's going to go, 6x minus 2. It is the common base. 3 squared is 9, so 3 to the negative 2 is 1/9. And then I just need this negative x minus 1 in parentheses. Base be gone. 6x minus 2 equals, I'm going to distribute, positive 2x, positive 2. I'm going to subtract 2x from both sides, get them over to the left. I'm going to add 2 to move the numbers over to the right, which gives me 4x, cancels, cancels, equals 4. And now if I divide by 4, I get x equals 1. Okay. Number 7. Through 12. Okay, before we even attack any of these problems, find the exponent. X plus 2. X. X minus 4. X minus 2. X minus 3. X minus 3. Now, look at the numbers that are attached to those. Think about the exponent as a balloon, and the base is the little kid holding the balloon. So number 7, who's holding x plus 2? That would be 2/3. 2/3 is a fraction less than 1, which makes it decay. The domain on all of these, we've talked about decay and growth is going to be negative infinity to positive infinity. Remember, growth generally looks like this, and that's not what we're doing here. We're doing decay. So decay generally looks like this. But it's going to keep going left slightly, and it's going to definitely keep going right on the horizontal. Range, we always look at this number here. Negative 1 to positive infinity. And that's going to be the same setup every time, unless there's a negative number in front, which means it's going to flip and go towards negative infinity. And remember, you can put this in your calculator just to verify. Now A is the number out here. There is no number out there, but don't be tempted to put 0. Because if you did, then everything would disappear. It is 1. Since there's no number, it's really an invisible 1. H, okay, remember, we go the opposite way. So x plus 2 means left 2, so that's negative 2. Because really, we can rewrite this as x minus negative 2. So it's x minus h. And then k is the number out here, negative 1. So transformations, we're going to go left 2 and down 1. And remember, since this is decay, you can always just put this in your calculator as a parent function and then compare it to this one and see what happens to it. Number 8. Who's holding the balloon? 3. If it's a number bigger than 1, then it is growth. Remember, growth generally looks like this. The domain on all of these, again, like we said, is negative infinity to positive infinity. The range we get from our k, 4. So it's 4. Okay, now here's the tricky part. This negative means now this is going to be going down this way. It flips over the x-axis. And that's why it's not a bad idea to confirm with your calculator. So normally, this would be 4 to positive infinity. But this time, it's 4 to negative infinity. And like I said, go ahead and type that in your calculator and confirm. Okay, so here we go again. For this one, it is going down, so it's negative infinity. A is this number outside the base. So 3 is our base saying growth. This 1/2 does not mean decay. This 1/2 is our A, which makes it wider. And so remember, A tells us whether it's wider or narrower. And then H, we're looking right up here. X plus 3, x minus 5. There is no change. So in this case, it's 0. I know that can be confusing. Why is nothing for A 1 and nothing for H 0? Because this is an x plus or minus 0. It's something being added or subtracted from the x. So since nothing is being added, it is 0. So the 1/2 is wider, and it also flips over x-axis because it's a negative 1/2. And then the plus 4, which is our k, moves it up 4. Okay, who's holding the balloon? 4 sevenths, which makes it decay. The domain does not change. Negative infinity to positive infinity. The range, we look here, negative 6, and since this is positive, a positive A, it's going to go up towards positive infinity, like so. So A is 1/3, H is 4, remember it's opposite, and K is negative 6. So the 1/3 makes it wider. The negative 4 means right 4, and the negative 6 means down 6. Okay. Who's holding the balloon? 5. So that's growth. X minus 2. All right, got ahead of myself. Domain does not change. The range, we get right here, 3. And since 5, there's nothing outside the 5 to flip it, it's towards positive infinity. Remember, growth generally looks like that. So there's nothing in front of the 5, so that's a 1. X minus 2, okay, so that's 2 for H. And K is positive 3. Transformations, the minus X minus 2 means right 2. And the K of 3 means up 3. And number 11, who's holding the balloon? 2. So that's growth. The domain does not change. Negative infinity to positive infinity because it's looking like this. The range, we look right here, 7. Now to know whether it's positive or negative infinity, we look out here. Since it's positive, this is positive. Now A, the number in front of the little kid holding the balloon, is 1/3. H is 3. And K is positive 7. So the 1/3 makes it wider. The X minus 3 moves it right 3, and the 7 moves it up 7. Okay, who's holding the balloon? A fraction. So that's decay, which looks like this, generally. But since it's negative, it's going to look like this. We have to look for all these things. Now the domain does not change. The range, we look right here to get that number, and then we look, and since this is negative right here, it's going to be negative infinity because it's going down. A is that negative 3 right there, which means it flips over X axis, and it is narrower because of the 3. H, we get from right here, X minus 3, so that means right 3, and the plus 4 is our K, and that is up 4. And remember, K also tells us our asymptote. So going back a little bit, number 7, the asymptote is y equals negative 1. For 8, y equals 4. For 9, y equals negative 6. Number 9, y equals negative 6 is the asymptote, and so forth. Okay, complete the table, graph each function. So again, let the calculator do the heavy lifting for you. So for number 13, you're going to put this in your calculator. It's going to be negative 1/2, or you can put it 0.5, raised to the power of x minus 2 plus 5. And then you're going to graph it. Actually, you're probably going to want to go to the table first. Okay. Negative 2 gives us negative 11. And I just went to that one because it's the closest one. Negative 1, negative 3, 0, 1, 1, 3, 2, 4, 3, 4.5, and 4, 4.75. So negative 2, negative 11 is going to be off the chart a little bit right here. Negative 1, negative 3, 0, 1, 1, 3, 2, 4, and basically we're never going to hit, whoops, as I just did, 5. So let me clean that up a little bit. That's where the wall is, at 5. And remember, Where is that wall? Right there, which gives us our asymptote equation, y equals 5. And if it helps you, put in a line, put in that electric fence right there to remember where to go. And remember, use your calculator. Let it do the heavy lifting for you. So the domain has not changed. It's going how far left? Forever, eventually. How far right? Forever, positive. The range. Remember, we look at K. And normally it's going to be positive infinity, but since there's a negative out here, it's negative infinity. The y-intercept, right there. You can write 1 or you can write 0, 1. Either way. I'll accept either answer. Okay. For the rest of these, I'm just going to hit pause and then have to calculate everything up already to save time. Okay, so I put this in the calculator. Not a lot of points to put on, off the chart. And then here's where we start getting into all of our close to negative 6. Oops. I moved my asymptote was off a little bit. Oh, that was a little off. So my asymptote is right there at negative 6. Right? And then, so there's only a few points you can actually put. But that's what it's going to look like. So again, the domain does not change. Negative infinity to positive infinity. The range, we get that from right here, negative 6. See it's going up. No negative numbers out here, so positive, positive. Infinity there. Y-intercept, right from the chart, 3 or 0, 3. And the asymptote we get from right here, y equals negative 6. So there's my graph. So again, right here, if you want to put this line in, the asymptote line first before you even draw it, it kind of gives you a guideline to remind you. The domain, again, does not change, negative infinity to positive infinity. Range, we get from right here, negative 4. Notice it's going up towards positive infinity. And again, this is positive, A is positive, so it stays positive. Y-intercept, right there, about negative 3.92, it's rounded. The asymptote, again, we get from K, which is y equals negative 4. Okay, so here are my values. That's my asymptote, so I'm just going to put my asymptote in right here. Then we'll put some points on. So 5, negative 13, 4, negative 5, 3, negative 1, 2, 1, 1, 2, 0, 2.5. So you can see it's going to come in now and not hit that wall. And again, it's going down because of that negative right there. So the domain does not change, negative infinity to positive infinity. But since A is a negative 1, and remember our base is 2, but we have a negative 1 outside, that's A. Since that's negative, it's flipping it over. So now, here's my first number for my range, 3, but it's going towards, actually I should put negative infinity first. We always say how low does it go first, and then that's positive 3. The y-intercept we get from right here, 2.5. And the asymptote, again, we get from right here, y equals 3. Okay, so here we are with our growth and decay and our compound interest. So just as a reminder, okay, and there's been some confusion with this. This one right here has to do with money. And you're looking for the keyword compound. Okay, so just because there's money in a problem, like let's say number 17, there's money in the problem. But that is just a decay problem. It is not decaying at a compounded rate. It's 7% each year. It's the same amount each year. This formula right here you're looking for this word. It is only when the amount is compounded each month. So you make some money in interest, and the next month you make money on the interest, and then you make money on that interest. That's what it means to compound. So in this formula, just having money does not make it a compound problem. Okay? So, number 17. It says a certain machine is valued for $32,000. That's our A sub O. Decreases means it's going to be decay. 7% is 0.07. And it says write an exponential function, show the depreciation. So that would be 32,000 times 1 minus depreciation, 0.07 raised to the power of t, which we don't know yet. What is the decay factor? The decay factor is the parentheses. That's another thing to talk about. If it asks for the rate of decay, then you would say 7%. But if you're doing the decay factor, it is this parentheses. Now remember, you might see the problem written like this. Okay, that is still a 7% decay factor. Find the value of the machine after 15 years. So that's 32,000. The board keeps going off. Try this again. Let's use the regular old eraser. How about that? One minus 0.07 raised to the power of 15 years. So you're just going to run that through your calculator. And you get a future value of $10,774 and 427, so round up to 43 cents. Number 18. There are 12 mice living in a farmhouse. The population increases, so that's growth, by 8%. So it's going to be 1 plus 0.08. Now, here's the thing. It says each month, 8% each month. What about a year from now? This number, t, has to be in the same terms as the percent. So instead of putting a 1 there for 1 year, we're going to put 12 months. And then we just calculate it. 1.08 raised to the power of 12, and then times 12, which is a different 12. That's the number of mice we started off with. Now it's 30.21, which is 30 mice. And even if it was 30.91, it would still be 30 mice, because we don't have that next mouse yet. Okay, population 14,600. 1. Population has been growing, so that's plus 2.8%, 0.028. Remember, to the left, to the left. It started in 2000. What will it be in 2025? That's a time period of 25 years. 1.028 raised to the power of 25 times 14,600 is 29,119.28. 29,119 people. Again, even if it was 0.99, it would still be 119 people. A mug of chocolate is 90 degrees when it starts, temperature, Celsius. If stirred steadily, the temperature of the hot chocolate decreases, so that's decay, at a rate of 1.7, that's 0.017, to the left, to the left. per minute, after 15 minutes, what's the temperature? So we do 1 minus 0.017 raised to the power of 15 times 90. 69.6 degrees Celsius. It's 0.58. So we just rounded it. Certain YouTube video begins with 1 view. It goes viral and increases. So that's going to be plus. A rate of 6.2, that's 0.062. 1 week later, remember it was per hour, so we need to take 24 hours in a day times 7 days. That's 168 hours in a week. So 1.062 raised to the power of 168 times 1 is 24,486.05, so 0.1 views. But you can't have, you're not going to have a partial view, so there's your answer. Okay, just doing some more practice. Number 22, the initial investment is right here, $14,500. That's a funky zero, I know. The interest rate, that's our R. It's not 0.062. Remember, we have to go back to the right, 6.2%. Number of compounding periods is right here, 4. Time of the investment. Remember, this is 4 times T. So 4 times T equals 48. So we divide by 4, and we get T equals 12. 12 years. Okay, 23. There's our key word. As soon as we see that, we know we're doing the compound interest formula. So we're putting $250 in the account. The interest rate is 0.017. That goes up top. It is compounded weekly. That is 52 weeks in a year. And that also goes right here. Times 18 years. So we do 0.017 divided by 52. Oops. 0.017 divided by 52 plus 1 raised to the power of 52 times 18 times $250. And that's going to give us $339.478. So 48 cents. 2 more to go. Okay, initial investment, $1,300. Rate, 0.043. Compounded monthly, that number goes here and here. 7 years goes there. So, 0.043 divided by 12 plus 1 raised to the power of 84, which is 12 times 7, times $1,300, which gives us a future value of $1,755.63. It's 0.627, so we're going to round up. Okay. This is a plan A, plan B problem. So option A is, first off, we know she has $5,000 to invest. This is going to be 1 plus, 1 plus. Now, option A is 0.065. Option B is 0.042. Now option A is quarterly, which means we put a 4 here and a 4 here. Option B is monthly, so we put a 12 and a 12. And it's going to be over 10 years, so times 10 times 10. So plan A has a higher interest rate, but not compounded as often. Let's see which is the better plan. 0.065 divided by 4 plus 1 raised to the power of 40 times $5,000. The future value of $9,527.79 is 0.793. Do it again over here. 0.042 divided by 12 plus 1 raised to the power of 120. 12 times 10 times $5,000. That only gets us $7,604.23. It's 229. So the better option, plan A. That's an R. Plan A is better. And there's your review. If you have any questions, you can email me or use Remind Me.